After decades of speculation and research, scientists have finally unlocked the secrets of the mysterious black hole. Join us as we delve into the groundbreaking discovery that has captivated the scientific community and shed new light on the mysteries of the universe. But if you don't want to miss out on more such space discoveries, subscribe now. Here we begin with our video. With this general theory of relativity, Albert Einstein predicted the existence of black holes for the first time in 1916. American astronomer John Wheeler coined the term black hole many years later, in 1967. After decades of only knowing black holes as theoretical objects, Cygnus X-1, the first black hole discovered, is located within the Milky Way in the constellation of Cygnus, the Swan. According to NASA, the first signs of a black hole were discovered in 1964 when a sounding rocket detected celestial sources of X-rays. Astronomers discovered that the X-rays were coming from a bright blue star orbiting a strange dark object in 1971. The detected X-rays were thought to result from stellar material stripped away from the bright star and gobbled up by the dark object, an all-consuming black hole. Using quantum computing to discover the inside of black holes, it is said black holes may be holograms. Indeed, the entire universe may be a hologram. At least that's one aspect of a recent study published in the journal PRX Quantum. The research takes a closer look at what's inside a black hole. It's also an attempt to comprehend the concept of holographic duality. Holographic duality is a mathematical conjecture that attempts to connect particle theories and their interactions with gravity theory. It's an intriguing concept, even if it does sound a little far-fetched. Essentially, holographic duality holds that gravity theory and particle theory are equivalent, at the very least mathematically. Thus, what happens mathematically in gravity theory also happens in particle theory. Both of these theories, for the most part, describe different dimensions. On the other hand, gravity describes 3 dimensions, whereas particle theory only describes 2. The researchers hope that delving into this concept would help them understand what's happening inside a black hole. Enrico Rinaldi, a research scientist at the University of Michigan, focused on these 2 theories in the new study. In Einstein's general theory of relativity, there are no particles, only spacetime. And there is no gravity in the standard model of particle physics, only particles, he says. Connecting the 2 different theories is a long-standing issue in physics, something people have attempted to do for over a century. Rinaldi and the other study members investigated holographic duality by connecting these 2 theories and using quantum matrix models. The idea was to combine what we know about particle theory with what we know about gravity theory. To begin, they use simple matrix models made up of number blocks. It is a standard framework used in quantum computers to represent particle theory using one-dimensional strings. These are typically used to assist researchers in locating the ground state, which Rinaldi believes is important because it allows you to create things from it. For example, the researchers could describe the gravity inside a black hole using the models they created. So what's inside a black hole? As you get closer to its event horizon, the infamous point of no return, we know what happens outside the black hole. The event horizon is the point at which the escape speed exceeds the speed of light. To escape the black hole's gravity, you'd have to travel faster than light, which is impossible for any bit of matter. Physics goes crazy inside the event horizon. Calculations indicate that the appearance of the fabric of space-time inside a black hole is determined by the black hole's history. It could be turbulent, twisted, or any number of other things. But one thing is certain, the tidal forces would kill you. According to theory, there is something called a singularity within a black hole. All of the matter in a black hole is crushed into a singularity. Some describe it as a point of infinite density at the center of the black hole, but that's probably incorrect. True, that's what classical physics says is there. Still, the singularity is also where classical physics fails, so we shouldn't trust what it says here. In a very specific mathematical case, a singularity in a spinning black hole becomes a ring, not a point. However, that mathematical situation will not exist in reality. Others argue that the singularity is a whole surface within the event horizon. It's possible that singularities don't exist in real black holes. Wormholes are theoretically possible if the proper conditions are met. However, those conditions would almost certainly never exist in the real world. What do black holes look like? The Space Telescope Science Institute, or STSCL, estimates that 1 out of every 1,000 stars is massive enough to become a black hole. Because the Milky Way contains more than 100 billion stars, our home galaxy must contain 100 million black holes. Though detecting black holes is difficult, NASA estimates that there could be 10 million to a billion stellar black holes in the Milky Way. The closest black hole to Earth is known as the Unicorn, about 1,500 light-years away. The nickname has two meanings. First, not only does the black hole candidate reside in the constellation Monoceros or the Unicorn, but its extremely low mass, roughly 3 times that of the Sun, makes it nearly unique. The outer and inner event horizons and the singularity are the 3 layers of a black hole. A black hole's event horizon is the boundary around its mouth beyond which light cannot escape. A particle cannot leave once it has crossed the event horizon. Across the event horizon, gravity remains constant. The inner region of a black hole, where the object's mass is concentrated, is known as its singularity, the single point in space-time where the black hole's mass is concentrated. Scientists cannot see black holes in the same way that they can see stars and other celestial objects. Astronomers must instead rely on detecting the radiation emitted by black holes as dust and gas are drawn into the dense creatures. However, supermassive black holes in the center of a galaxy may become shrouded by the thick dust and gas surrounding them, blocking the telltale emissions. When the matter is drawn toward a black hole, it can ricochet off the event horizon and be thrown outward instead of dragged into the maw. As a result, bright jets of material at near relativistic speeds are produced. Although the black hole cannot be seen, these powerful jets can be seen from a long distance. The image of a black hole in M87 taken by the EHT required 2 years of research even after the images were taken. Because the collaboration of telescopes, which spans many observatories around the world, generates an astounding amount of data that's too large to transfer via the internet. Researchers hope to image other black holes and create a database of what the objects look like. The next target will likely be Sagittarius A, the black hole at the heart of our Milky Way galaxy. According to a 2019 study, Sagittarius A is intriguing because it's quieter than expected, possibly due to magnetic fields suffocating its activity. Another study that year discovered a cool gas halo surrounding Sagittarius A, providing unprecedented insight into the environment surrounding a black hole. What would happen if you fell into a black hole? If I were a stellar mass black hole, you'd be dead before you passed the event horizon. This is because if you imagine a black hole as a pit, a stellar mass black hole has steeper sides than a supermassive black hole. As a result, the tidal forces become too powerful too quickly for you to make it to the event horizon, resulting in your spaghettification. You wouldn't notice much passing through the event horizon, except for some fun light effects and a few extra G's of gravity. However, gravity would stretch and squeeze you like dough in a bread machine as you got closer to the singularity. You'd die at this point. What do you think of the black hole and its inside? Share your views in the comments below and subscribe for more.